number 6. Again, my numbers are a little bit off here. Excuse me for that. So that's going to be number 6. And if you recall, we had an edit here, and we're going to make that 8 seconds just so that we stay consistent. This is the same problem that we worked on question 3. It was the one on the front of this sheet. It was about a train which had an initial velocity of 3 meters per second, speeds up to 7 meters per second in 8 seconds. So you've seen this scenario before. The first question asked what its acceleration was. Right now I'm asking how far does the train travel in those 8 seconds? So let's look at what we have. We're just doing the same kind of thing we do every time. So we got 3 meters per second to start. 7 meters per second is our final velocity. The time that we're doing that acceleration is 8 seconds. I don't honestly care exactly what the acceleration is this time. What I care about is how far the train traveled. So let's go ahead and do some graphing to see what we can do with this. As always, you've noticed maybe that we're going to always do a velocity versus time graph, okay, just to kind of get our sense of what's going on here. So we're starting off at 3. I'm going to go ahead and count by 2. So there's 1, 2, there's 3 meters per second, and we're going to go up to a velocity of 7. So that's 3, 4, 5, 6. So there's 7 meters per second, okay? And we're going to do that in 8 seconds, and I'm going to go by ones here. So 1, there's 2, there's 4, 6, 7, there's 8 seconds, okay? And I want to know how far the train traveled. Not exactly sure what to do yet, so let's go ahead and graph it, because graphing can tell us a lot of things. So again, it's going to start at 3 seconds. We're going to go up to 8 seconds, or excuse me, start at 3 meters per second, go up to 7 meters per second. After 8 seconds have gone by, make sure I'm lining this up correctly here. We're going to go like this. And our line, just like it did in question 3, looks like this. Okay, so now we have to figure out what we're going to do with that, because we're looking for how far did the train travel. So really we're looking for the displacement, okay? And we can recall that displacement is going to be measured in meters. So we're going to take a look at what we've got. Again, we've got meters per second on our y-axis and seconds on our x-axis. And again, we're looking at this kind of like we did in the last question. Our seconds can cancel on the bottom and the top, which is going to give us units of meters. That is what we're looking for, displacement. So now we've got a perfect opportunity to solve for the displacement. Just like we did in the last one, we're going to look at the area under the curve, or the area between the curve and the axis. This one's a little bit different though, because now there's my curve, and here, way down here, is the axis. So instead of just doing a triangle, in this one, we're going to actually look at the whole area, this area of the trapezoid. Now, some of you may remember this from geometry, how much fun it is to find areas of trapezoids. If that was not one of your favorite things from geometry, I'm going to remind you that in this case, we can look at this trapezoid as a rectangle and a triangle. And as long as you add those two areas together, you're finding the same area. So if it makes you happy to do a trapezoid, you go. I'm going to do it the triangle and rectangle way, because that seems a little bit more straightforward. So again, to find the displacement of the object, one option is to use the area between the graph and the axes. So let's say on a velocity versus time graph. So we're going to go ahead and find that area. So we'll do it in 2 pieces. We'll do the easy one first. So we're going to find the area of that rectangle. So that's going to be the area of the rectangle is length times width, or base times height. The length, if I go up this way, is 3 meters per second. And the width across this way is 8 seconds. Oh, come on. 8 times 3 gives me 24 meters. Really what that means is if If the train had traveled just at 3 meters per second for those 8 seconds, it would have traveled 24 meters, okay? But we've got to include this little blue triangle on top because the little blue triangle is giving us that additional distance that it traveled as a result of its acceleration. So the second part here, we're going to find the area of that triangle. Remember, that's 1/2 length times width, or base times height. 1/2. The length here is going to be this distance here. Okay, so that goes from 3 to 7, so that's going to be 4 meters per second. The width is going to be the same as it was. It's going across the bottom. That's 8 seconds. Okay, so we've got half times 4 times 8. Looks like it's going to be 16 meters. And so our total distance that we're traveling is going to be the 16 plus 24. So we'll add those two things together, 16 plus 24. And it looks like that is going to be 40 meters total. Again, that's your displacement. That is how far the train traveled during those 8 seconds.